What is up, guys? Welcome to JS Racing. My name is Jason. Today we are going to be working on the electronics part of the Inertia Dyno project that I said I'll be working on. The reason why it took so long for me to kickstart this project again is really because the PCB board that I needed to print really took a long time for some reason, and also I had to source the correct sized flywheel, and like it has to be a correct weight and diameter and all that, so that took me a long time. But now that everything is in place, it's time to put everything together and see if it works. Now, the reason why I chose Inertia Dyno, after having looked through online of all the homemade dynos, it looked like the Inertia Dyno was closer to what I was hoping to get out of a dyno, because like there are a few types out there, but those types don't really have like consistent recording of like a wide range of RPM and torque. I only had like a very distinct point of reference. So like for the water pressure, you have to put the engine at a certain RPM, then you can work out the pressure and all that stuff. So if you really want to be very detailed in like the horsepower range of your engine, like from 1000 RPM all the way down to 6000 something, then you have to really manually do it and record it every time. So that I think it's going to be too complicated for me to operate. And also with the water pressure, it can build up to quite high levels, and it looked kind of dangerous to me, so I didn't want to do that. And then the other one was like a pressure plate version, which required like the engine put pressure on this arm, and then the arm would sort of put pressure on this pressure plate, and then you can calculate the torque because the distance of the arm and all that. So I didn't want to do that because again, it doesn't record a full range of power from like the lowest RPM all the way to the top. So at the end, I sort of decided on Inertia Dyno. I started researching, and luckily there's this YouTuber called Two Stroke Stuffings, and he does a lot of amazing projects. But this particular one is he designed an Arduino shield, he called Ardyno, and he's put all the instructions, components, everything online, and it's really made it quite easy for anyone to follow and just put it together. So as long as you have the right hardware and all that, it should be quite easy for you to build an Inertia Dyno that will be working with the software called Simple Dyno that you install on PC, and it'll be able to record a full range of like torque, whatever, and then help you calculate the horsepower of the engine. So hopefully I'll be able to make it work, because the software Simple Dyno was actually originally designed for RC cars. So to convert it to like a combustible engine, all that, there are a lot of information online, but it's very like scattered. It's all like forum based, so I'm gonna have to really dig through all the information and troubleshoot, because everyone, like, from time to time they run into problems and all that. But anyway, so that's after I finish building a thing. So anyway, let's get back to today's objective. Today is basically going to be building the shield. So I'm just going to be following the instructions, building the shield, installing onto the Arduino board, upload the software onto the Arduino board, and then basically just testing it with Simple Dyno. And I think it should be quite simple. The instructions online is basically just one page. So yeah. Anyway, so that's basically today's objective. The next video, part 2, will be building the flywheel, all that, the contraption, and then installing the electronics onto that. But yeah, I think that will take a bit more time because I need to sort of custom make some little parts on it. But it should be okay. Anyway, so without further ado, let's get started. Alright guys, so that's pretty much the Arduino shield, Ardyno, done. Looks decent, but I have to say I'm not too sure about this diode, because on the board the negative terminal is actually on the round side, the flat side is the positive terminal, but on the diode the negative terminal is on the flat side, and then on the round side is the positive terminal. I don't know if it's like diodes are different, but I installed the diode according to the diagram, which is the flat side on this side, so hopefully it'll work. If not, I'll just have to take it out. But the instructions said that the diode is more optional, so I can have it or not have it, but we'll see. Let's try out the next steps and install it onto the Arduino board. Alright guys, so that's pretty much the shield done. Now it's just a matter of, see these legs that I soldered? It's basically attaching them to these, and yeah, and that's it. It's a pretty easy fit. But the problem now I have is I don't know what power source I should use for this one. I didn't buy it when I bought the package. I just bought the board, so don't know if it can be powered just by USB power source. But anyway, you're gonna have to figure that out. Alright guys, so I've added the Hall sensor that is recommended by Two Stroke Stuffings to use as a sort of RPM sensor for this particular project, and I've tested that the USB-C works as a power source. So let me just show you guys. Just plug this in. Yep. Doing that quantum position thing again. There you go. It comes on. So I'm guessing that means it's powered on, right? Anyway, so nothing's burning, nothing's blowing up. So I'm guessing everything's soldered on properly. Anyway, so let's upload the software, the sketch, onto the Arduino board first. Alright guys, so for the next step, what we need to do is download the Arduino IDE software from Arduino website. So that's easy enough. After you download it, it's very simple. You just open it. It looks like this. I already have the sketch file opened, but anyway, so I'm going to show you the next step. So the next step, okay, we need to find Simple Dyno. Now, Simple Dyno, you won't be able to get it from this link. It's broken. So what you need to do, just go on any browser, search for Simple Dyno on GitHub, click on the first link, should get you here. Okay, so just download this program and install it, unpack it, install it. Now the sketch file, you need to find it inside this folder. So let's go in, and that's the sketch file. It's right here. It ends with .ino, so that's what you need to get. So next step, okay, so next step, after you install Arduino, after you get the sketch file, after you unpack the Simple Dyno, what you need to do is open the Arduino IDE, okay, which looks like this, and then you should find the sketch file, which for me, I stored it in JS Racing project, and then Simple Dyno here, and that's the sketch file. Okay, well, this is the sketch file. Once you go in, it should look like this. Okay, so let's just close that. It should look like this. There's not a lot of codes in there. Now, this is when you need to plug in your board. Once you plug in your board, go to Tools. Okay, make sure you got the board is selected as the one that you want, which in our case should be Arduino Uno and the Arduino Uno R3 for me. Okay, there are a couple of versions. I bought the R3. Then the next one is you need to select the correct port, which for me is the USB serial port. Once you have that selected, you got the sketch open. All you need to do, select the board here, and then you just click upload. Once you upload it, and that's it, you're done. Okay. The next step, we'll have to move on to Simple Dyno. Now, Simple Dyno is only available on PC. I'm using a Mac here, but I do have a PC, so we're going to switch to PC now. Now, before we move on to the PC, there is a very pretty comprehensive documentation that comes with the Simple Dyno software. Okay, so it just tells you how to install it, how to set it up, and the best part is, let me just show you this real quick. Okay, so here it is. Simple Dyno was written to support DIY Inertia Dyno projects by providing a simple way to monitor the RPM of a dyno roller or flywheel. Okay, to calculate the torque and power produced, the software needs the moment of inertia of the rotating parts using basic parameters such as roller diameter, roller mass, all that blah blah blah. So all you need to do is just input all the correct parameters in there, and you'll be able to get a reading from the Inertia Dyno. So this software should be able to work with our project no problem. So all we need to do now is just set up the software first, test it, see if it works, and then we'll move on to the next step, which is the hardware part. Okay, so the next step will all be done on the PC. Now on the PC, when you open the Simple Dyno, the first thing you'd see is this. This is a very typical view. It's the default view of the Simple Dyno, and this is basically all the controls that you need to care about. So in the Simple Dyno, when you first open it, this would actually just say audio only, okay? And it will only say one channel. Now, once you have the Arduino board plugged in and you have all the drivers installed, you should be able to select COM port only or audio and COM port, but really you just need the COM port, and you'd be able to select this. The baud rate is 9600, so don't change that, because in the sketch code it's set at 9600, so just leave it at 9600, otherwise it won't be able to read it. Now the zero detect is basically the amount of time, so this is actually in seconds. So when the software is sort of like detects that the roller is no longer producing any RPM data, within half a second it'll just stop. Okay, so that's what it means. So you can set the time at like 1 second or half a second, whatever, depends on you really. But yeah, you can refer to the documentation to see what sort of setting is best. The documentation actually suggests 1 second, I think. Now for the advanced, this is more for audio only or audio and COM port settings, so you don't really need to use this. Again, you can refer to the documentation. Now, if you don't see COM port appear or any of the COM port related options appear, then it means your driver is not installed. So quit the program, install drivers, and then plug in the board again, and then open Simple Dyno. It should show up. Now the second thing that you may notice is that when you're testing the sensor, maybe nothing happens here. Like you'd see this green line continuing to draw and it receives no data. Now there are there's one very simple reason for that. If you look here, it says RPM 1. So when you first install the Hall sensor, it's actually RPM 2. So we just need to go to RPM 2, and then you just go to actual RPM, and now you should be receiving data from the sensor. So I'm actually swing this. So this sensor, every time it goes past the magnet, it will produce a bit of data. So that's what you need to attach to the flywheel. Now that's all basically the basic settings that you can do. Next thing that you need to do is the dyno. So in the dyno setting, this is where the important stuff for the Inertia Dyno comes in. So you need to know all of these parameters so that the dyno is able to work out the correct values for the horsepower, torque, whatever. So make sure you understand what these are, and then you input the relevant information in there. So for the flywheel, if you're using a flywheel, it's actually the roller. So anything related to roller, then you just input the size of the flywheel. Then you have the axle that connects to the flywheel, and if you have like a brake disc, okay, so you can say end cap mass or extra diameter or whatever. So there's a lot of written information here, so you can just refer to that. Now if you have more sensors, what you can do is come to the COM port, and then you can do calibrations here, but that's a bit more advanced, and that really depends if you have like all these extra sensors. But for now, we're just using the Hall effect sensor for the RPM, and you need an extra cable for the engine RPM, so you can show it up here as well. I'll show you. There's an option here. So RPM 1 motor, actual RPM. Okay, so this is a cable that you need to wrap around the spark plug, which is pretty much the same thing as you'd do with the AIM micron controller, the computer. Anyway, so that's pretty much all the important things that you need to understand with the Simple Dyno. It's a pretty simple program, but it's actually quite elaborate as well. So there's a lot of stuff that you can set for the display of the data and stuff. So this is pretty good. Now, one thing I want to show you guys is that all these boxes they're pretty much customizable. So what you have three types. So you have label. So label looks like this. Okay, that's what label looks like. Okay, and you can close that actually. If you don't want that, you just close it. Oh shit. So let's just open another one. Yeah, default view. Oh, to close it, you just double click, I think. Yeah, double click. So for label, what that basically does is that it just shows one value at any given time. So if you're talking about the RPM, then it will just show one number continually increasing or decreasing, whatever. Now, if you have a gauge, blah blah blah, that's what it is, and then you have Y versus time, that's what that is. It's a graph and it's all customizable. So to customize this, like the information shown is anything above this line, anything above that line, you can have it shown on these information modules. Now if you want to customize the colors, then it's actually below this line. So you have like the Y range, the minimum, maximum, and then you can set colors, you can set the font, refresh rate, you can do every 10 milliseconds, whatever, configuration and lines and points, blah blah blah. So everything is customizable, which is great. So what I did is I made my own view. Oh shit, no. And that's what it looks like. These are basically all the information that I need for now, but I will be adding more, like temperature and all that stuff eventually, because I will be needing that. I will be adding 2 more sensors. So anyway, that's pretty much the software. Anyway, so that's pretty much it for all the electronics software portion of this Inertia Dyno. It's pretty easy. All you need to do is just follow the instructions. Now, the instructions really didn't show some of the things that I had to figure out myself, so I actually spent quite a bit of time figuring the stuff off camera, but I basically explained everything in the final chunk of the video about the software and all that. So if you guys have problems figuring out what's wrong, feel free to leave a comment. I'll see if I can help you out with that. But as long as you follow the instructions, it's actually quite simple in how to create this electronics component, and then eventually the Inertia Dyno itself, which we will be working on all the hardware stuff in the next video. So that will take a bit more time because I need to start ordering the parts and also customize some of the components. But yeah, hopefully I'll be able to get that done within the week or a week and a half, something like that. But yeah, it's quite a success today, all the electronics and stuff, so it worked quite well. And eventually I will be looking into how to expand on the sketch, and probably maybe I'm going to work on the Simple Dyno software, because I do have a friend who is a software developer. I might be having them look into it and see if we can make it even better, because the Simple Dyno software has actually been dead for quite a long time. So I think it's about time we update it. But anyway, so that's it for this video. Hope I drummed up some interest in you for creating your own Inertia Dyno. And if you guys have any cool ideas, feel free to share it with me in the comments. So anyway, that's it for this video. I'll see you guys in the next one.